Hello and welcome to CosmoQuest's live coverage of the launch of the BepiColombo satellites. We are 31 minutes and 10 seconds away from launch right now, and we are at the point of everything so far is looking good. And I'm going to go ahead and work to bring in beside me the coverage of the mission. Pardon me while I try and get it to fix a little bit better. So currently over on ESA's live stream, we have folks talking about, well, the launch. So let's listen in.
Scientific missions like this, you don't decide overnight. You're true, Thierry. It's a very important adventure, a long one. It started back in 2006 with the development with the industrial partners, but in fact, it started even earlier with scientists who started, European scientists and from other countries started studying.
So the ESA coverage seems to include people talking over people over people. It's a bit confusing. So tonight's launch is coming to us from French Guiana. We have an Ariane 5 rocket that has perched at the top of it the BepiColombo satellite, which has two different spacecraft piggybacked together. One of these spacecraft, okay, here we go. Let me cut into this and see what they have to say.
And Gunther Hasinger, Director of Science at ESA. Welcome to you both.
Thank you very much.
Gunther, let me start with you. I think it's a fair question. People want to know, it costs a lot of money, takes 7 years to get there. Is it worth it going to Mercury?
Okay, yes, that's a very good question, and I believe that this is a relative question depending on how much you are willing to spend. When you think about that, every European is basically every year.
I just want to say that's the worst possible question you can ask a scientist. Don't do that.
If you think about how much material for the cinemas we are actually producing, we are much more worse than a single cinema ticket. And I mean, not just jokingly, I think the inspiration and the fascination that we are creating in the people's minds, and in particular in the young generation, is really crucial in order to get people into professionals like STEM professions, but also the general public just to learn more, to get excited.
Okay, very good. You're going to have to share the microphone. Gentlemen, Dr. Saito, yes. we have two orbiters. This one is yours, is that correct?
Yes.
Okay. Now, this is called the MEO, or the
yes.
MMO?
Yeah.
Yeah. All right, tell us about that. What's its role?
Okay, the MEO's role is to understand the Mercury's magnetosphere. By 5 onboard experiment, MEO is going to measure magnetic field and surrounding plasma environment, and also including the solar wind interaction. And MEO also measures the sodium atmosphere of Mercury and also the dust environment. And Mercury's magnetic field is much weaker than our Earth, and the Mercury has no atmosphere. So in the extreme environment of the Mercury, the strong solar wind and strong solar radiation will easily interact with the Mercury's surface. And it affects the structure and dynamics of the Mercury's magnetosphere. So MEO is going to make the comprehensive measurement of the plasmas and resolve the still poorly explored Mercury's magnetosphere.
Okay, Gunther, which one is yours? Can we see yours here?
Okay, so ESA's orbiter is this one, MPO, and then ESA is also responsible for the transfer module, which brings us to Mercury, and also the sun shield to save MEO from the hot sun.
Okay. Sorry, I was going to ask you. Go ahead.
No, so you wanted to ask me what is inside?
No, I want to ask you what's the advantage of having two spacecraft?
Okay, I mean to have two spacecraft.
We'll get to the other question afterwards.
For the subject that Saito-san is mentioning, the magnetic field is a three-dimensional structure. It also depends on the solar wind. It changes, and so if you measure it from different angles, you can get much more information than just from a single angle. Okay. But also, the fact that we are basically looking at the same object from different times, also different instruments, is giving us a lot of additional information about the composition, the chemistry, about Einstein's theory of relativity, and so on.
Okay, good. Dr. Saito, last question, rather briefly, if you don't mind.
Yeah.
Why study the magnetic field?
Well, when the magnetic field of the Mercury was discovered about 40 years ago by Mariner 10 spacecraft, it was a great surprise. But the magnetic field of Mercury has not yet been fully understood.
Okay.
So making
This is going to help us.
Okay, so making measurements, Mio will solve the mystery of the Mercury's magnetic field.
I'm sorry, I have to cut you off because we're out of time. Gentlemen, many thanks. Back to Terry now for a first look at the launch vehicle.
This is an ESA broadcast. It's a bit awkward.
So let's get back to this launch vehicle, still in the Guyanese night. Some numbers to define further this mission. So we'll look at this Ariane 5 and its passenger tonight. Ariane 5, this is a heavyweight version.
Okay, so what we're currently listening to is an English translation of a French broadcast that is being simulcast in the background. I'm just going to mute them for a moment. Let me move this so that you can see it. This is a big rocket, is essentially what they're saying. They are launching from French Guiana. This location is spectacular for a number of different reasons. On one hand, if this was a takeoff during the day, one of my favorite things is they always scare the bejesus out of giant pelicans. That has nothing to do with the launch. It's just fabulous. The actual amazing reason to launch from French Guiana is they're closer to the equator. This means that the Earth's rotation is able to give them extra velocity that they can't get if they go further away from the equator. As you go further and further north or south, your velocity going around the rotational pull of the planet goes down. Hold on, looking to see what they switched to doing.
Many times that science is the backbone of ESA.
Yes, science was the origin of ESA, and science is still the backbone. It is a special method how we are dealing with the science program. It is not top-down, which a Director General would love. It is bottom-up. That means the scientists are deciding what to do, and therefore science is really the backbone with new missions like the BepiColombo.
Mm-hmm. Now with BepiColombo is part of a wider program of deep space probes. I'm thinking of the Jupiter-Ganymede mission, and there are others. Can you tell us BepiColombo's place in that program?
So if you look into our science program, we have a lot.
So I'm noticing what Susie's saying in the chat. This is actually a European Space Agency launch. So this is coming out of ESA and is produced by ESA. So this isn't NASA TV. So they're currently asking questions about how big ESA is. So I'm just going to tell you about the spacecraft. So this is our first mission to Mercury in 14 years. The last mission that we sent to Mercury was the Mercury Messenger mission, which you can actually be part of over at CosmoQuest.org. I'd actually encourage all of you, if you have extra screen real estates, go open up CosmoQuest.org and map out Mercury while we wait for this spacecraft to launch. Now, the Messenger spacecraft was a NASA mission. It also had instruments from collaborators, and it was the first mission since the Mariner missions to do a mapping of Mercury, and it was the first mission ever to go into orbit of this innermost planet. Now, where it paved the way, BepiColombo is now going to follow in its, thrusters, I guess. And this mission is going to take 7 full years to get to Mercury. The reason that it has to take so long to get to something that is in many ways so reasonably close is it has to lose speed in a very precise way so that it can match orbits with Mercury, but not fall into the sun. Getting into the sun is extraordinarily complicated because if you screw up, you die, and death is generally bad for spacecraft and everything else. So in this case, they're going to very gradually move their orbit further and further inward. Looking to see again what's coming out of ESA.
Thank you, Joshua. In particular, all is going according to plan. I can tell you that we are 14 kilometers away from this launch pad, number 3, where the launch vehicle has been waiting since yesterday as it was rolled out from its last assembly building and, after being given the go-ahead, and it's waiting there. We will now go through the major highlights that will be pacing this mission. There are no launch windows tonight, and the liftoff is scheduled some 20 minutes from now. BepiColombo arrived in Guyana on the 24th of April, and this is when the campaign started, and everything is now ready for liftoff tonight. A few key moments, as we said: liftoff in Universal Time, 1 hour, 45 minutes and 28 seconds, 22 hours and 45 minutes and 28 seconds Kourou time, 2 minutes, 21 later, separation of the solid rocket boosters at 3 minutes 09, separation of the fairing. The launch vehicle and satellites will be followed by 5 successive tracking stations, as you all know, all of which will be on its journey to the east. Everything starting from here in Kourou with the Galileo station at 8 minutes 43, jettisoning of the main cryogenic stage, and in the same breath, 4 seconds later, ignition of the upper cryogenic stage. After a mission that will be quite short, the separation velocity will be 10,155 meters per second, and altitude will be 49 kilometers, and at 26 minutes and 47 seconds, separation of the satellite BepiColombo en route to Mercury, with a 7-year journey, and a fabulous one indeed. So we will meet again in December 2025 for the first data reported back from the 2 probes, one under the aegis of ESA and the other one JAXA. So this around Mercury. As we heard earlier, if there's one area where international cooperations are primordial, it is the space industry. You cannot go it alone in space. Joshua, as you said, and now you are with one of the representatives of the Japanese JAXA agency.
Right. BepiColombo Joint Mission.
Okay, I'm going to cut this guy off because one of the things I want to explain to you is just how crazy awesome this orbit is. So I'm going to fully admit this is a Wikipedia page, but they had the animated GIF I wanted to show you. So what we see in this animation right here, and let me see if I can enlarge this. Whoops, that did not. Okay, let me see if I can enlarge it and keep it on the screen. So this animation that's currently on the screen is one that depicts how BepiColombo is going to, here we go, take off, go into an orbit that's slightly larger than the Earth, use the Earth to bend its orbit, go in, encounter Venus, use Venus to bend its orbit in further, and then work its way into an orbit around Mercury. This is a complicated set of gravity assists that are going to make this possible. And one of the things I haven't talked about yet is the mission's name actually comes from the scientist who figured out, well, exactly how you do this kind of a gravitational assist. So in celebrating a scientist, they're not celebrating someone who did amazing things with Mercury necessarily. They're celebrating the person who made their spacecraft possible. So we are now at 16 minutes and 40 seconds away from launch. You are all welcome to ask me questions. I will do everything that I can to answer them. Now, one of the things that I'd like to do is give you a understanding of exactly, pardon me while I rearrange things on my screen, what is going to happen after launch. So here we go. This is a ESA graphic that was put together. So the first thing that we're going to have at launch plus 2 minutes is the boosters will separate off. At 3 minutes, we will have the protective fairings that curve around the spacecraft at the top of the rocket drop off. Now we need those fairings because our own atmosphere is going to create a whole lot of drag. By putting those fairings over the spacecraft, they decrease drag, they decrease how much fuel is required, and they also protect the spacecraft from the trials and tribulations of passing through the Earth's atmosphere. Now, as we all learned watching The Martian, if you don't have a lot of atmosphere, you don't need the fairing, the nose cone. So at 3 minutes, once they're high enough up from the surface of the planet, those fairings get discarded, and then at 9 minutes, the main stage will separate away. At 40 minutes, we're going to hopefully receive our first signal from the mission. Now we are back to watching someone talk in French while getting translated in real time to English. Let's listen to the translations.
Thematic places of this Guyana we love so much. Therefore, today we are heading off to the Île de Salut, these islands off Kourou. We will be flying over this volcanic archipelago in a few seconds to discover, indeed, 3 islands which form this archipelago, the Île Royale, Île Saint-Joseph, and the Devil's Island, all of which are volcanic in nature and are attached to the Cayenne municipality, CNES being the owner of these islands. The Île de Salut owe their name to the tragic Royal French expedition conducted in 1763, the Choiseul expedition, which resulted in the death of some 12,000 people in a year, and the survivors took refuge on these islands where the climate was more friendly and mosquito-free. This is why they renamed them Île du Salut. Then the jail was built there to receive the first political deportees. Alfred Dreyfus and Guillaume Cesnac were the most famous of the prisoners jailed there. After the closing of the jail in 1947, the Guyanese Space Center saw the light of day in 1965 and turned these islands into a strategic location because they are placed under the trajectory of the various launches installed on the Île Royale as early as 1969, launches to the north. One of the follow-up facilities was the Kiné Theodolite, which is an optical instrument for graphic trajectory location, and now has been turned into a Kiné telescope with as its mission to observe in the visible world and infrared any significant events from the liftoff to the first stage separation. Since the 1980s, tourist has developed on the islands, and there has been a will to safeguard the heritage with the buildings like the Chapelle Royale or the House of Dreyfus. Île Royale and St. Joseph are open to visitors, which is not the case to this day for the Devil's Island, which is still closed to the public. So a favorite spot for tourists, these islands are reachable.
Okay, while they talk about tourist things, I'm going to go ahead and answer the question from the chat. The question was, what do scientists hope to learn by studying Mercury's magnetic field? Well, first of all, it will help us understand how does the internal dynamo of Mercury function? Is it liquid on the inside? What is its moment of inertia we'll be able to get by having these spacecraft orbit around it? And by understanding, is it solid all the way through, and what is its magnetic field, we'll be able to combine this information to try and figure out what generates the magnetic field in Mercury. Is it something that you might say is baked in? Is it something that is coupled to the sun's magnetic sphere? how exactly does all of this work? We know that Mercury rotates extraordinarily slowly, with one day taking a significant fraction of its orbit. It's not actually tidally locked, but it's pretty close. Hold on, I'm listening in.
8 seconds until liftoff BepiColombo on the Ariane 5. Now remember, according to the professionals, countdown is the most intense part of the entire campaign for the mission, the campaign lasting roughly 6 weeks when the satellites first arrive here. We're going to, as Thierry said, present some of the key players in the mission tonight. We like to do that in the beginning of the broadcast. The people making the mission happen. This is the Ariane Space High Command, also called the Flight Desk, headed up by Stefan Israel, whom you saw. With him, Roland Lagier, the Chief Technical Officer. And these gentlemen will make the call should anything unexpected come up, either before or during the mission. You might see them on the phones to the teams here across the space base or back in Europe. Ariane 5 is ready for her mission. You might recall also that Ariane 5 is the reliable workhorse vehicle and the senior member of the Ariane 5 with Soyuz and Vega. Ariane designed for heavier satellites like tonight's. Coming up next, you're going to see the green status panels, a very important part of the mission, both especially before the mission. They are a real-time summary of everything that it takes to prepare, to launch, and to follow Ariane. You can see in the upper left of the screen there, it's behind us here in the hall on the...
Okay, I'm going to cut him off and go back to answering questions. Hello, everything is random. So, and you can see everything's green. So we have all greens. We're good. He's simply saying everything is all green. So everything is random. I first started streaming in March, I think, of 2017, but I really got involved in doing it in October of 2017. So I'm still one of the fairly new streamers around here. I've been doing physics and astronomy pretty much, well, not physics. I've been doing astronomy pretty much my entire life. And I'm going to have to embarrassingly admit, I got into it via science fiction. I was a little kid, totally in love with Battlestar Galactica. And one thing led to another, and I have a PhD in astrophysics. So sometimes weird connections lead to weird places. So I see Star Stuff Studios is saying there's a solar electric propelling transfer module. Can you explain this method of propulsion? I meant to dig into it after I first saw that. No. I'm sorry. That's a bit embarrassing to admit to. In general, spacecraft are dead to me until after they've successfully launched. And for this one, I looked up what it will be capable of accomplishing and what the mission will do when it gets to Mercury. And I kind of put blinders on. I'm so sorry, but I'd rather admit to having no clue than make something up. So Disillusioned is saying Venus is insanely hot, but Mercury is closer to the sun. Which is hotter on the surface? Venus is actually hotter on the surface. This is because Mercury is able to radiate away heat, whereas heat on Venus just builds up and builds up and builds up. So the energy that hits it doesn't all get to escape. So one of the things that they're talking about right now is this is an instantaneous launch window. This means that when the Ariane 5 takes off, it either has to do it at the right moment or not at all. The instantaneous launch window comes about because they have to be waiting for the planet Earth to be pointed in the exact right direction. They're going straight from on the planet to leaving Earth's orbit at an escape velocity and heading out into the first orbital transition that they'll make as they work to spend 7 years, gravity assist at a time, working their way towards Mercury. They have to take off at the exact right moment or they don't get the right orbit. So we're going into something in French. Hold on.
All right, there we are.
So we're at 7 minutes.
7-minute mark brings us into what's known as the synchronized or the automatic sequence. It's a key milestone representing really the tip of the iceberg, the final moments of final countdown. A complex series of operations running right down to liftoff, making the launcher autonomous. Our stage is set. I'm going to go up to the broadcast booth. While I'm doing that, take a look at a film on the launcher campaign to see how Ariane is put together for the.
Okay, so I'm going to mute that. So I see Ben Science and Games is asking, when will the first manned mission to Mercury be? I can't tell you when the first manned mission to Mars or the moon is going to be, and Mercury is a much harder problem. Now, this isn't to say there isn't a way to safely exist on Mercury. If you're a sci-fi buff, as I'm clearly admitting to being over and over and over again during this particular stream. If you happen to be a science fiction aficionado, you might have read Kevin Stanley Robinson's, I think it's 2049 series. One of the books in this series talks about having a colony on Mercury that exists on a planet-wrapping railroad. And as the world ever so slowly rotates compared to the sun, the colony on these railroad tracks remains forever at the terminator, at this point that is neither frozen nor broiling with heat. So Mercury is tentatively possible. Venus that we know of really isn't, at least not at the surface. Upper atmosphere, there are people who've talked about deploying balloons, having some sort of a cloud station, not with humans, but for science platforms. So yeah, this is where we're going. Fenmil, I can't actually tell in the background whether it's French or German, but for a long time the standard language of ESA was French, so I am making an assumption there, and this is coming from French Guyana. Star Stuff Studios, this is a crazy orbit. 7 years for it to get everything right. And then to uncouple, and hopefully both spacecraft will deploy successfully. So this mission, Disillusioned, is going to go to Mercury, and it's going to insert the two spacecraft that it's carrying into two separate orbits. There's going to be an imaging mission that's going to go into a lower orbit that allows it to get significantly high-res images, and there's going to be a magnetic probe that's in a higher up orbit. Looking to see if there's other questions. Did I totally mispronounce something astro-wise, or are you commenting on something else? It's true, Larry. We don't know when people will be going to the ISS next. Okay, switching back to the broadcast booth.
Of ESA's BepiColombo Project Scientist. Wonderful title. What's the job about?
Oh, hello and Ohio gozaimasu, Japan. Yeah, being project scientist of such a mission with two spacecraft and the collaboration between Europe and Japan is such a fascinating job, because you have dealing with all aspects of science, and you are the interface of the scientist, you deal with the engineers, you steer the science operation, so it's a great job.
Terrific. We'll hear more on that in a moment. But for now, we want to take the cameras up to the Launch Campaign Operations Center, where the teams are working, several teams up there, under the direction of this fellow, Rafael Breda, who's the Launch Complex Operations Manager. Several teams up there, as we said. One is responsible for the ground operations, the other for readiness of the Ariane 5. The Launch Campaign Operations Manager heads up one group, and he coordinates with Mission Control for final authorization to launch, and when all the conditions are right, he then okays the automatic sequence at the 7-minute mark, which we just saw, in all about 100 people up there.
So we are now 2 minutes and 30 seconds away from launch, and our broadcast is at the stage of, oh dear God, please let everything work. We're going to just talk quietly to scientists while everyone goes through those moments where your lizard brain cuts in and you suddenly become spectacularly superstitious. Here we go. So Star Stuff Studios, I think it would actually be kind of horrible to be that close to a launch when it occurred. When these spacecraft launch, they shake everything. You feel it in your chest. And I'm not sure I'd want to feel it that much in my chest. Now, there was a question earlier where someone, I'm sorry, it scrolled out of the way, said that they put their KSP spacecraft into a polar orbit. Well, in this case, no, we don't have enough ability to change orbit. So the spacecraft is taking off in the plane of our solar system. It's going to be interacting with the Earth, with Venus, with Mercury to get itself into the correct orbit. And at that point, it's just not going to have what it takes to hang a right-hand corner. So let's switch over to their audio and watch launch.
Top à 0-1 minute.
And
So
there we are
1
into the
minute.
final 60 seconds as the crowd gathering on the terraces. Give us a chance to say hello to our friends at JAXA Tokyo, Airbus in Friedrichshafen, to our industrial partners, ESA, including ESAC, where we'll go
And I do
momentarily,
believe that was French.
and CNES, and to all of you following the broadcast on the internet. We hope you are enjoying it. We're going to cut away now and let you listen to the DDO as he calls out the final countdown. Watch for the cryogenic arms to open and enjoy the liftoff.
I love how it kind of looks like a race car with all of the logos all over it. This amuses me for more reasons than it probably should.
À tour de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage 2EAP, décollage. Propulsion est nominale, la trajectoire est nominale.
The roar of her engines, a lot of fire, and with a BepiColombo on board, the DDO says all is well. The two boosters now providing 90% of our thrust, propelling the launcher along her trajectory at an ever higher velocity. 780 tons at liftoff, that's the mass. And to get that sort of mass off the ground, you need a lot of push. And push we have. She's burning 5 tons of fuel every second. 2.5 tons being burned every second in each booster, plus the core stage burning another 300 kilos of fuel every second. Ariane 5 putting on quite a show. And I can't wait for Johannes to come back and tell us his reactions. The sky is clear. You should be able to see separation of the boosters, maybe even separation of the fairing. We'll find out momentarily. Ariane 5 now following the program and the onboard computer, which gives all the orders, including stage separation. We'll soon see that in just about 30 seconds from now. We are in the first of 4 flight phases. The first 3 are powered, and we'll describe each in turn so you can follow. Right now, the first flight phase, the single first stage engine, and the 2 boosters are burning. The boosters will each consume their 240 tons in just over 2 minutes, and in just about 10 seconds. They will be the first to be extinguished, and you'll hear that from the DDO, but you'll see that on the screen. You'll see the flame out there.
Pilotage calme, trajectoire nominale.
There it is. You see the main point of light in the middle when we come back to that, and the 2 points of light on either side are the boosters. That's what it looks like up there. There's another booster on the port side, of course, out of camera range. But you see the main point of light looks like the moon in the middle, and on the side the 2 boosters flaming out, and they will fall into the Atlantic. French Guiana, in part chosen as a base for its opening on the ocean, launches posing no threat to the local population, of course. We're waiting for Johannes to come back. before he comes back, our next milestone, separation of the fairing. That's next up as we continue to follow Ariane with looks like a ground camera or the naked eye.
Séparation de la
The
coiffe.
launcher making here, the DDU has called out separation of the fairing. And this is what that looks like. There's another half on the starboard side, which is falling into the Atlantic as well. We can separate the fairing now. Why? Because we're out of the dense layers of the atmosphere, of course. Over 100 meters altitude. And you can see on the bottom of your screen on the left, our altitude 140 kilometers. And on the right, our speed, 2.4 kilometers per second. We can also discard any dead weight. The fairing, excuse me, weighs 2.5 tons, so it's a good idea to get rid of it now that we can. The guests coming in after being treated to a wonderful sound and light show. On the left there is the satellite, the white boxes. Below that is the composite. One reason Kourou was chosen as the launch site was its nearby hills, where we could install radar and telemetry facilities. And that's where we're going now, this office.
So sorry for that. I screwed up. So what I was saying is when we had the image that was strictly the bright point of light from the engines and they were trying to keep it in the center, that was actually one of the most complicated things that we can do in following space launches. Telescopes aren't designed to track across the sky as quickly as a rocket moves. So the way they're able to capture images like that is custom software is written that centroids. It keeps centered in the same place on the image as best it can the rocket engines. Software doesn't always succeed all that well. And there we can totally see what Fenmil was talking about with that's a model rocket next to the launch facility. So we now have a safe launch. We now have booster separation, fairing separation. We are coming up in 3 minutes and 30 seconds with the main stage separation. After that, well, it will be at 27 minutes. We have spacecraft separation from the booster, and it won't be until 40 minutes that we receive our first transmissions from the spacecraft. Now, I'm going to stay with you until at least the 9-minute mark, and then let's see where things are going. Again, I'm quite sorry for the mute error. I clicked the wrong audio track. So here's what Larry is saying. Larry is asking, it is software borrowed from target systems? Actually, no. This is software that is borrowed from telescope tracking and just sped up a lot. Telescope tracking systems usually say, okay, here's a star, here's the brightest pixel in the star, let's keep these things lined up over time. And with spacecrafts like this, those telescopes have to update how fast they do it. And instead of just using the fine guidance on a telescope, they have to actively slew at high velocity. So let's see, is there anything else? Panic basket, I think that was a fair emoji to use carbonaceous. Yes, there is, Paranor, lots of independent work on tracking going on. So there is no text over the video that is currently showing. They are simply highlighting with dramatic music the variety of different missions the European Space Agency has launched over the years. Many of these spacecraft for a lot of decades were built in direct collaboration with NASA, and there's still partnership between the two different space agencies, particularly with the Hubble Space Station. Not Hubble Space Station, Hubble Space Telescope. So here we are back to a animation. They have data coming in from a downrange tracking station, and everything continues to look good. Thank Thank you, Star Stuff Studios. I hope to catch you later. So CosmoQuest, they can track these things using all sorts of different kinds of systems. But yes, Alt-as definitely works way better when you're dealing with tracking rockets on the go. So Ben Science Games, I can't tell you when Pluto orbiter and lander will be launched. I can tell you there's lots of people that would love to do that, and Alan Stern continues to campaign for more missions to the outer solar system. Now, one of the things I want you all to think about as we wait for our spacecraft wait for our main stage separation. This mission has been in preparation for a couple of decades. It's going to take 7 years just to get to Mercury. There are scientists that will start their career, go gray, and start to worry about their retirement savings, all before the spacecraft they started on makes it all the way from proposal phase to getting there. Okay, so they're saying that we have cutoff and separation of the lower stage. Here goes the animation, and everything is coming in as A-OK. So they're saying we're now in the final powered stage.
5:10, or another 16 minutes roughly. The job of the upper stage, taking the satellite to its injection point, positioning it for separation, and then releasing it. That's its propulsion role. But she also has a second role, and that comes during Ariane 5's what they call ballistics phase. Our next film from ESA, an overview on the BepiColombo mission.
Okay, so let's go ahead and give this one.
Fueled and almost ready to go, the final assembly of the BepiColombo mission to Mercury. A collaboration between ESA and the Japanese space agency JAXA, BepiColombo consists of 2 scientific orbiters, a transfer module to propel them to Mercury, and a sunshield. Protected by hand-stitched ceramic thermal blankets, the entire spacecraft is 6.5 meters high and will only just fit inside the fairing of its Ariane 5 launcher. Designed to withstand temperatures of up to 450 degrees Celsius, BepiColombo is one of the most technically and scientifically complex missions ever launched.
80% of our material needs to re-qualified for this mission because we hadn't tested before in that harsh environment. So it's a real challenge to go there and to bring 2 spacecraft in an orbit around Mercury.
The first challenge is getting to Mercury. Flying directly isn't an option. The sun's gravity means any spacecraft would be going too fast to make it into orbit. Instead, BepiColombo will take 7 years to reach its destination, combining solar electric propulsion with a total of 9 flybys of Earth, Venus and Mercury.
When we fly, we constantly brake against the sun because we fly into the inner side of our solar system. And when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. This is why we decelerate.
Once they arrive at Mercury in late 2025, the orbiters will separate from the transfer module to begin their comprehensive scientific mission in 2026. With its 11 instruments, ESA's Mercury Planetary Orbiter will study the surface and internal composition of the planet. Meanwhile, JAXA's Mercury Magnetospheric Orbiter's 5 instruments will study the planet's magnetic field. Together, the orbiters will not only reveal more about Mercury, but also the history of the inner solar system.
Because Mercury is not tilted like Earth, it's spinning almost in the orbital plane. Therefore, there are some craters on the poles which never see sunlight. And in these craters, we found water ice. And this water ice could be stable over millions and billions of years. And that's a fantastic thing also about Mercury.
ESA science and engineering teams have been working on BepiColombo for more than a decade. With a long journey ahead of it, the launch marks only the beginning of the next stage of BepiColombo's voyage of discovery.
I'm taking Terry's place for the moment out here on the terrace because I want to introduce to you Johannes Benkoff. You heard his voice, but you haven't seen him. So if we get the camera on him or the drone, well, there we are. I have a question for you, and I may have to cut you off because we're going to go to Isak. But briefly, mission life, BepiColombo, 8 years. Why 8 years?
Yeah, it takes us a while to go there. We need 7 years to go to Mercury, and then it's 1 year of nominal mission. We hope that we maybe can get an extension of 1 year, because the spacecraft is also designed to last 2 years in an orbit around Mercury.
How do we get an extension?
Oh, you need to make a proposal with our agency, but if everything is good, then I think I'm quite confident that we will get this.
Okay, let's get the word from Isak. We'll go to Darmstadt. We're going to speak with Paolo Ferri, head of operations there. Paolo, can you hear us? We're coming to you live from Kourou.
Yes, I can hear you very well.
Great, okay. We want to ask you a few questions. We don't have a lot of time. But first I want to ask you, what's the mood at Isak? How would you describe it out there?
Well, everybody here is very tense, waiting for the signal to arrive. As you know, we lost the telemetry at the moment of liftoff, so we're not in contact with the spacecraft. And our job will start after the separation of the spacecraft from the rocket. So we are really looking forward to that moment.
So the mood from liftoff was what? Concentrated, focused. I don't want to say tense.
Yes. Yes, certainly tense, but everybody excited. We've been preparing for this mission for so many years. We were really looking forward to this moment. Now it's the time to go.
Okay, this moment is this moment. What happens next, both in the short term and in the longer term?
Yeah, in the short term, after we have acquired the first signal in a few minutes from now, we will have the team working here for about 2 to 3 days, getting the spacecraft ready for its long cruise to Mercury. There will be some activities like deploying antennae for the communications when the distance increases from Earth, and of course checking that all the systems are ready. Then there will be a more, let's say, a longer phase of a few months where we test the onboard systems, the payload instruments, and very important will be
I'm going to have to cut you off. I'm terribly sorry. We have to go to a film, but Paolo Ferri, many thanks.
I'm sad. They keep interrupting cute, adorable little scientists, or not little, elder scientists for movies. So now we have a very loud movie. Let me turn it back. Okay, so there is no words to go with the loud movie. So we have a rock and roll rendition of what Mercury is doing. I'm out. Ask me questions. I don't know what to say at this point. I'm deeply amused by this video. It's high quality, but the music is very dance club. Very, very dance club. Yes, Star Stuff Studios. I totally agree. I totally agree with that. So do you guys have any questions? Okay, we now have an ad for Airbus. And there's another view of mission control with the model Ariane 5 standing next to it.
Be picked up by our downrange tracking station in Libreville in Africa. You're watching Ariane Spaceflight 245.
I touched nothing. They went mute on their own. I'm not sure what just happened. They may have lost audio from ESA or maybe having issues in their control room. I don't know, F. Bill, what the next American launch is going to
right
be.
Is BepiColombo. Now, what are we looking at? That's the sun shield on the extreme right?
Extreme right, we see the sun shield, and behind the sun shield, the Japanese spacecraft is hidden.
All right, we'll be back with more. We're going to go to the film on JAXA and its role on the mission.
Okay, I'm just going to lower the volume on that a little bit. So the next big event for science missions that we can look forward to is the InSight mission landing on Mars. That's going to occur towards the end of November, and then December 31st, January 1st, depending on where you are in the world, we're going to have the New Horizons mission doing a flyby of Ultima Thule. So we don't have a lot of things in the pipeline right now. We don't have a lot of funding in the pipeline right now. That's a conversation for another day. But here we are. Oh, do I know what the main objections of the probes are? Sorry, Disillusioned. I just couldn't quite read through your particular typo. So we have the European vehicle is going to do high resolution imaging, if I'm getting this right. And let me double check this before I inadvertently give you misinformation. So we have two spacecraft. They're going to separate and bring us different aspects of Mars. The one spacecraft is going to go into a lower orbit, and it's going to do high resolution imagery. The other one is going to do magnetic imaging. So I am looking at the two different spacecraft now. We have the Mercury Planetary Orbiter. This is the European Space Agency mission. I did have this correct. And it is going to be doing laser altimetry. This is where you bounce a laser off of the surface of Mercury and measure how long it takes the laser light to return. Based on the travel time, you can tell just how far away the surface is and very carefully measure surface features. There is also an accelerometer, which will be used to map out the gravity and the moment of inertia, which starts to tell us just what is its internal characteristics. There's a magnetometer, radiometer, gamma ray, and neutron spectrometry that helps us figure out things like, is there water under the surface? There's an imaging X-ray spectrometer, radio experiment. They're going to be studying the outer exosphere. This is the very, very non-dense. Vacuum is a closer word, atmosphere around Mercury. Then we also have the JAXA mission, which is going to be studying the plasma particle conditions around Mercury, the magnetic field, and also studying the sodium atmosphere and dust around Mercury. So those are the instruments that we have to look forward to. Yes, December does bring us a comet, and that is always exciting. So yes, Paranor, water ice has been found on Mercury. It exists in the always shadowed regions on the surface. So we have 3 more minutes in the upper stage burn, and once that has occurred, we can basically say, there she goes. So the next main occurrence is going to be the spacecraft separating. Thank you, Star Stuff Studios, for the subscription. The next primary activity is going to be the spacecraft separating away from the small booster that it's still attached to, that is firing to make sure it gets into the correct orbit. Once that has occurred, she's off and flying on her own. At 40 minutes after launch, there will be acquisition of signals. Currently, we are following the spacecraft using telemetry stations here on the planet Earth. But at 40 minutes, she starts sending us back signals on her own. Then at 74 minutes, the spacecraft will deploy its solar arrays. And then at 18 hours, it finishes deploying everything that's left. Within 3 days after launch, the spacecraft is going to be fully checked out and on its way cruising along in orbit. Now, one of the things I did want to bring back up for those of you who weren't here earlier is a animated GIF, however you want to call it, of the orbit that this spacecraft is going into. So BepiColombo, which again is named after the scientist who figured out exactly how these gravitational transfers, these gravitational boosts and assists can be used to get a spacecraft from A to B. Well, let's take a look at what the spacecraft is going to be doing. This is the orbit where initially the spacecraft shown in purple is going to go in an orbit slightly bigger than our Earth's. It's then going to use the Earth's gravity to bend its orbit into a smaller orbit. It's going to interact with Venus multiple times. And finally, it's going to end up in an orbit where it interacts with Mercury repeatedly until it's able to settle in and match Mercury's orbit. And this is an incredibly complex set of timings that they have figured out, where we needed to launch this mission when the Earth, Venus, and Mercury would all be timed out precisely right to allow these things to happen. Now, the spacecraft that we see here with its booster still attached, this is an artist rendition, this is not the actual spacecraft. Once the spacecraft gets to Mercury, it's going to do its first flyby in 2021, and it's going to enter orbit on December 5th, 2025. So we are getting some word from Mission Control. No, they're just talking to each other, sorry. So here we go. And thank you all for all of your support. For those of you who are new to our channel, we are affiliated with CosmoQuest.org. CosmoQuest is here to put science in your brain. We are working to engage you in both learning and doing science through the streams we do here and through the citizen science projects we invite you to participate in over at CosmoQuest.org. So we are 3 minutes away from the separation of the booster probe at the back end of this spacecraft. Now, this is one of the few missions we have ever sent towards Mercury. It has, in fact, been 7 years since we last had a Mercury mission, and that was NASA's Messenger mission. Prior to that, we were looking at the Mariner missions, which occurred before I was born. So Nancy is asking, had tonight's launch not occurred at precisely the required moment, how long would they have had to wait before the next launch opportunity? So they do have a few days for their window, and each day they have a different instantaneous launch window. But I don't remember exactly how long the total launch window. I believe it may be like we had with the InSight launch window, where it was an instantaneous window, but not InSight, the Parker Solar Probe, where the Parker Solar Probe had a couple of months that it could launch during, but it had to launch at the exact right time to get launched on the correct trajectory. And now you're discussing peanut butter. I adore our channel's chat. And we have confirmed separation. We have applause coming into us. Let me go ahead and we can listen.
So there's the good news, at least on the scheduled program of events. However, we have to wait for confirmation. Can we get a reaction from you?
Yeah, I'm as relieved as the others, but still we are not there. We have to wait until we get the signal, and we have to wait until we have the successful deployment of our solar arrays and the antennas and everything.
So, as they say sometimes in the political world, cautious optimism.
That's correct.
I guess
Yes,
is the order of the moment. We have to wait for full confirmation of separation to see if it has occurred properly. The signal will tell us that BepiColombo has been sent on her proper orbit.
The
solar
signal
arrays
that they're
are due to be.
We won't be getting the signal that they're discussing that confirms that everything is A-OK until T plus 40 minutes. We are currently at roughly T plus 30 minutes. So in about 10 minutes, we will receive our first signal from the spacecraft. Wait, did someone just give a sub to Nightbot? I did not know you could gift a sub to Nightbot. I am so confused. Oh, that makes sense, Disillusioned. That is fabulous. Paranor, you have a new tool at your disposal. That... You learn something new every day, and I have now learned something new. Thank you so much for teaching me that hugely amusing thing. That is awesome. Okay, so you can see just how happy everyone is. This is awesome. Okay, so I feel like I've been in that room. So we are now 10 minutes away from getting... Wait, let's listen to this.
The escape orbit and is now on its way towards Mercury. For its 5th mission of the year, Ariane 5 has performed flawlessly. Congratulations to all. Today's new success marks the beginning of a 7-year trip for BepiColombo, taking advantage of gravitational assistance from Earth, Venus, and Mercury. What an exciting journey. After the missions Mars and Venus Express, Rosetta, Herschel and Planck, Gaia, Arianespace is very proud to have contributed to this new major scientific success. So I would like to express my deepest gratitude to ESA Science and especially to its director, Gunther Hasinger. Gunther, I think it was first time for you in CSG, so so it was a good time, obviously. And ESA DG Jan Werner. Jan, thanks for being with us tonight. After BepiColombo, we are looking forward to next Arianespace mission for space exploration, the launch of the famous James Webb Space Telescope. Let me also thank ESA's partner for BepiColombo mission, the Japanese Space Agency, JAXA, which deliver the Mercury Magnetospheric Orbiter. In this regard, I would like to address my congratulations to Mr. Hiroshi Yamamoto, JAXA Senior Vice President. I would like also to congratulate Airbus Defence and Space, which successfully delivered the Mercury Transfer Module and the Mercury Planetary Orbiter. I want to thank Airbus Space System and its CEO, Mr. Nicolas Chamussi, for being in CSG tonight with us. We have with Airbus many links. Airbus is the shareholder with Safran of Ariane Group. Airbus is also a provider for Ariane thanks to its subsidiary, and Airbus is the satellite manufacturer tonight. We have 3 more satellites to deliver by the end of the year with Airbus, so obviously you are important for us. Congratulations also to all other industry in the team and notably to NEC. The success of our 5th Ariane of the year would not have been possible without our European launchers dream team. Delivered to an escape orbit, this mission was a bit special. Our engineers have had to work hard to tailor it, showing the versatility of Ariane 5. So let me double congratulate all our partners for this new success. ESA and all the member states of the Ariane program whose support is essential. Ariane Group, Ariane 5 prime and first shareholder of Arianespace, CNES, Ariane 5 Design Authority, and our daily partner here in CSG, our contractors in French Guyana, and all employees of the launch facility. Of course, I would like to pay my tribute to my Arianespace colleagues for this new outstanding achievement, our first towards Mercury. So I would like now to welcome to stage our customers and partners. Thank you very much.
Ladies and gentlemen, it's really a great day, and I can tell you I'm really, really happy. Thanks to all who made this big journey so far possible. It's just the beginning of the trip, but it's already a great day for ESA. It's a great day not only for ESA. We heard already it's the first launch from CSG to another planet. It is also, of course, the first launch of with an Ariane to another planet. When I thought about this mission to go to Mercury, okay, you know the distance from Earth to the Sun, 150 million kilometers. You know the distance of Mercury to the Sun, it's 50 million kilometers. So the difference between both is 100 million kilometers. I calculated the mean velocity of the spacecraft, and I came up with 28 days. And then I learned that they are not using this shortcut, but instead of that saying it takes 7 years. I said, what the hell are they doing? Why are they flying so slowly? I mean, it could be done in 4 weeks. But, and this is the secret, it is Giuseppe Colombo, who was really the father of this mission, because he said, if you do this, as a civil engineer would do it, then you are ending up directly in the sun. And this was not our intention. So we want to go to Mercury, and we want to orbit Mercury. And therefore, Giuseppe Colombo made a very special method, flybys, and we have everybody is talking about electromobility. This is electric mobility, we have to say, in a very special way. We are not accelerating with electric mobility, we are decelerating. This is also interesting. So we have a solar electric propulsion on board. Now an interesting number to that. We have about 580 kilograms of xenon on board. The yearly production on Earth is 600 kilo per year. So we have just 20 kilograms rest for other activities for 1 year. So this is therefore, it's a very special electric propulsion, and it's therefore very important. And therefore I can just say, let us go together to Mercury, or in Japanese, Tuishi ni susei ni ikimashou. Go, Bepi, go. Thank you.
Thank you, thank you, thank you. Thank you very much to Arianespace. Thank you very much to Jan. This is really breathtaking. We have today written history, and we have sent the most complex stack of spacecrafts that ever have been conceived into space, onto a very long journey into an environment which is truly out of the Earth, truly out of this world, hot and dangerous, and we are going there where nobody else ever, well, not quite true, but anyhow, boldly go there. So, and this is the time to really say thank you. We have already heard a lot of thanks, but I would really like to thank all the hundreds and thousands of individuals who have made this success possible. Everyone, we are standing on the shoulders of giants, and the giants are all of you. And I would first like to thank the two space agencies, ESA and JAXA, for making this possible. I would like to thank our member states for bringing the finances and bringing the energetics and the instruments on board. I would like to thank industry, in particular the lead industries in Europe, ADS and TAS, and also NEC in Japan, for making this possible and leading teams of many sub-industries and engineers that really did technology development, which is unique and has never been tried before, to bring us there. The managers of the agencies are also a very important element of guiding and kind of controlling us through this very important and complicated exercise. I would like to thank the scientists, in particular the scientists who led instruments. You have heard that we have 16 individual instruments, and behind each of these instruments are teams and sub-teams and PIs and co-PIs, and I would really like to thank all of those. Their work will only start when we do the first flybys and then finally end by Mercury. We don't have to wait for 7 years. We can actually already get science when we are flying by Venus twice. Even maybe at the Earth flyby, we can at least calibrate the instruments, and all the Mercury flybys are also going on. And I would like to thank the operations teams who have actually worked very, very hard, trained, and are now taking over, basically in this minute or in the last minute, taking over the spacecraft. And I would last not least like to thank Ariane Spass for bringing us to the second into the exact orbit that we need, and so on. And so a huge, giant leap for mankind has happened today, but a very, very tiny step for BepiColombo, which still has to go 1,000,000,009 or whatever miles, I forgot it. And by the way, I would like to check on the health of BepiColombo. How is BepiColombo doing? And I would like to give back to Isaac to tell us about where we are standing there.
So we're in the process of waiting desperately to
Paolo,
find
do you hear
out
us at Isaac?
to find out if there's been signal acquisition. Signal acquisition is expected sometime between launch plus 36 and launch plus 44 minutes. They have removed the clock. We are now looking at the screen. I'm going to guess that that bleep was acquisition of signal. There's a little tiny bleep. I don't know if that was signal, though.
We can see the telemetry. The team is checking.
So if you can't hear them, he's saying we can see telemetry.
Wonderful. Thank you very much. Then I would like to hand over to...
Ben, sorry, they can't quite make that for you.
Yamamoto-san. Thank you very much.
Okay, we're going to listen to one more speech, and then I'm going to call it an evening.
Okay, good evening. My name is Shizuo Yamamoto, Senior Vice President of JAXA. It's a great honor for me to be here for the marvelous view of the successful launch of Ariane 5 carrying BepiColombo spacecraft. Firstly, congratulations to the BepiColombo project team, ESA and JAXA, who have worked so hard for many, many years. I'm very pleased to share this memorable event today with ESA as our partner of the BepiColombo missions. Especially, I'd like to express our sincere appreciation to Director General Dr. Warner and the ESA team for their efforts of this remarkable cooperation over the years. I'd also like to express our gratitude to CNES and Ariane Space, Airbus Defense and Space, NEC, and Kourou Launch Operation Team for the excellent launch operation at Guyana Space Center today. As already informed, BepiColombo spacecraft was separated from Ariane 5 and just began its long journey of more than 8 billion kilometers to the Mercury. It was a long flight from Japan to Guyana for myself, but it is nothing compared to the distance from the Earth to the Mercury. As for the mission of the BepiColombo, many scientists in the world are aiming to unravel the mystery of the Mercury by conducting a comprehensive observation of both its surface and interior using the two orbiters. One is developed by JAXA MMO, and the other one is developed by ESA MPO. These two orbiters will jointly travel to the Mercury for the next 7 years, and will start observation after arriving Mercury in late 2025. JAXA is committed to the success of the BepiColombo mission and other space science program like Hayabusa 2, MMX, SLIM, GRISM, and so on. And international cooperation is essential for these missions. So I strongly believe that through the success of BepiColombo mission, collaboration between JAXA and ESA, as well as Japan and European countries, will further strengthen and will contribute to the advancement of the future space program itself. Bon voyage, BepiColombo, and once again, congratulations and thank you so much.
Good evening, everyone in French Guiana. Good morning to our friends and colleagues in metropolitan Europe, and especially at the Airbus premises in all over Europe, and especially in Friedrichshafen. Thanks, Friedrichshafen. But also at ESOC in Darmstadt. And good afternoon to our friends and partners in Japan. Of course, I would like to warmly thank Arianespace and my friend Stéphane, where are you? Ariane Group and their industrial supply chain throughout Europe for having developed, produced, launched such a reliable, powerful, and efficient Ariane 5 launcher, and relentlessly heading towards the Ariane 6. And Stéphane, as you said before, you still have 3 satellites to deliver for us until 2018, and you know how important a partner you are for us. Of course, I would like also to praise ESA's leadership, Jan, Günther, for having put together and led the development of such an important and magnificent BepiColombo mission while entrusting us Airbus as prime contractor. Of course, I would like also to congratulate our Japanese friends with whom we have interfaced over the last years to develop such an international partnership. And of course, a launch success is only possible thanks to the close coordination of CNES. Jean-Yves, thanks for being here today, of course, and the Kourou Spaceport teams. And last but not least, of course, I would like to pay a warm tribute to the Airbus teams throughout Europe and our industrial partners for their professionalism, engagement, dedication for having imagined, developed, integrated, tested, prepared for launch of such wonderful space systems. A very, very warm thank you to all of you. Please allow me, nevertheless, one last word on today's launch from another perspective. One could look at it from 2 different angles from an industrial point of view. Either the launch of another spacecraft developed in Europe, including contributions from the UK, leaving Europe to the unknown world of a remote planet. Or the launch of a paragon of what Europe can do at its best, in this case under the leadership of ESA, with a solid and truly European prime with a top-notch European supply chain. As far as Airbus is concerned, we are talking here about probably one of the most complex scientific satellites that we have ever developed so far, taking the benefit of almost all of our sites in Europe. Friedrichshafen, Stevenage, Toulouse, Ottobrunn, Bremen, Portsmouth, Tres Cantos, Paradas, Leiden, and probably missing some of them. And in very, very good cooperation with the friends from Thales and Aerospace in Italy, we'd like also a special mention to Kinetic for the electric propulsion subsystem, and Azerspace for the solar cells, which, you know, given the specifics of this mission and the need to develop dedicated products to cope with. This is indeed an amazing mission with this 9 slingshots maneuvers, as Günther, you have pointed out, around the Earth, around Venus, Mercury, serving scientific purposes and filling the inextinguishable need of man to discover new worlds, developed in an international cooperation environment, in this case with Japan. One of the best examples of leading forward, looking, ambitious and successful Europe. The one I personally love, and the one I will further support the expansion of. Good luck, Bepi. Happy to have received first news from your telemetry, and we'll meet again in 7 years from now. Thank you.
And that is going to conclude our coverage of the BepiColombo launch from French Guiana. This mission was first conceived, or at least first published, I just found the earliest publication about it, in 1999, which means someone had already thought about it, proposed it, and gotten through the competitive process in 1999 when this notice of the naming came out. This mission has been, well, 2 decades in the making, and we have another 7 years to wait while it works its way slowly but surely towards the innermost planet to the sun. I can't say we're still going to be streaming 7 years from now because technology changes faster than spacecraft fly. But I can tell you that we will definitely bring you, however the technology may tell us to, our coverage of the orbital insertion of Mercury when this little spacecraft gets to the innermost planet. So thank you all so much for joining me this evening. This has been a production of CosmoQuest, and I invite all of you to help use the already existing messenger data to map out Mercury before BepiColombo gets there. So join us over at CosmoQuest.org. Now tomorrow we will be bringing you special coverage here on this channel of International Observe the Moon Night. Follow us on Twitter to get all the details about when we're going to be going live. As always, thank you for being here. Give us a follow if you want to find out when we're going live next time. And we are sustained through your subscriptions, and every bit really matters. Thank you all so much for being here. And wherever in the world you may be, have a fabulous morning, evening, or afternoon. And remember, get outside and look up. Bye-bye.